Hey guys, it's Mr. Mock, and as promised, I told you I'd do number 28 from the chapter study guide. So it's on page 661, and this is the one with Leslie paddling his kayak at a bearing of 45 degrees. So that's this way. In still water, his speed would be 13 kilometers per hour. So we should note that here: 45-degree angle, 13 kilometers per hour. But there is a 5 kilometer per hour current moving west, which is that way. Alright, so what is the resulting speed and direction of Leslie's kayak, which is the ultimate question. So basically, he should be in still water going this way at 13 kilometers per hour, but we have this current here, right? Moving him back this way. So really, we want to see how is that affecting his path as well as his speed, right? So that's going to be this line here. It's going to show his path and his speed. Alright, so we're looking for this leg here. We can call that X. Okay? So we have to kind of look at what information do we have. We have a triangle, we have a 45-degree angle, we have X, and we have two sides. This is kind of setting us up nicely for a law of cosines. So here's how that's going to work. We've got our c squared equals a squared plus b squared minus 2ab cosine of large C, right? So we know this is our angle, so that's going to be C. It's 45 degrees. Little c then is going to be opposite of that. That's what the law of cosines shows us. So that's going to be x. That's what we're looking for. We have a, which is, we'll call 5. We have b, which is 13. Okay? Cool. Now from there, we're going to go ahead and set everything up. So x squared equals, we'll have 5 squared plus 13 squared minus 2 times 5 times 13 cosine of C. And then that'll give us 25 plus 169 minus, so that's 2 times 5 is 10 times 13 is 130 cosine of C. And then 25 plus 69, so it's 9, that's 14, 8 and 9 would be 194 minus 130 cosine of C, and we'll have the x squared here. So basically we're going to be doing the square root of this whole thing right there. And what you're going to get when you do all that is x is going to be approximately 10.1. Okay? So that means this is 10.1, or 10.1 kilometers per hour. So Leslie is, instead of going 13 kilometers per hour, is going 10.1 kilometers per hour. Alright? And now it's asking for, at what bearing is Leslie going. So right here is a bearing of 45 degrees from here to here, but with the current pushing Leslie this way, we need to know bearing from here to this new line. Okay? So we need to find this angle here, and we can just call that angle, I don't know, angle T. Why not, right? So we need to find this one. So here I'm going to start using the law of sine. So I've got this angle, sine of T to 5, and we have the sine of 45 to 10.1. So I can do that work down here. I can't even tell if this is in focus right now. So the sine of T over 5 equals the sine of 45 over 10.1, and ultimately what you're going to get, the sine of T equals 5 times the sine of 45 over 10.1, and then T is going to be the inverse sine of this. And when you do that, you're going to find that T is going to be 20.5. But remember, this whole angle here, if T is 20.5, this whole thing here is 45. So we actually have to subtract 20.5 by 45, and you end up getting that his new bearing is 24.5 degrees from north. Alright, I hope that helps. It's a longer video, 5 minutes I'm pushing here, and I can't quite tell if I'm in focus or not. Ooh. So there's that work, and there's that work, and I hope that helps, guys.